Daniel Bernoulli was an 18th century Swiss scientist and mathematician who studied fluid through pipes. His discovery, now called Bernoulli's Principle, can be stated as, where the speed of fluid increases, internal pressure decreases. Bernoulli's principle is about the behavior of a fluid, a gas or a liquid, as it flows through a pipe or tube. It states that when the pipe narrows or widens, the fluid pressure and speed vary. As the pipe narrows, the speed of the flow goes up and the pressure goes down. When the pipe widens, the fluid flow slows down and the fluid pressure goes up. Bernoulli's principle is a consequence of the conservation of energy. The law of conservation of energy states that energy may neither be created nor destroyed, but takes on various forms. In this example, as the ball rolls down the hill, the loss of potential energy is converted into kinetic energy, illustrating the law of conservation of energy. So more speed and kinetic energy means less pressure, and more pressure means less speed and kinetic energy. Bernoulli's principle states that an increase in the velocity or speed of air decreases the air pressure. Likewise, a decrease in flow velocity causes an increase in air pressure. Low pressure is like a vacuum which pulls things toward it. A wing is curved on the top and flat on the bottom. So when a wing moves through the air on top of the wing has to travel faster than the air under the wing. Because the wing is curved on the top, the air moving over the top must travel further and faster than the air under the wing to get to the same place. This causes a decrease in the pressure on the top of the wing. The pressure difference from the top and bottom of the wing causes a vacuum effect, and the wing is pulled upward and lifts. That is to say, the difference in pressure between the upper and lower surfaces results in lift. Lift is commonly associated with the wing of a fixed-wing aircraft, but lift is also generated by propellers, kites, helicopter rotors, sails, wind turbines, and other streamlined objects. The propeller blade is an airfoil. Increased velocity means increased lift. When the airplane is flying at a high angle of attack, meaning the angle between the lifting body's reference line and the oncoming flow, the downward moving blade has a higher resultant velocity, therefore creating more lift than the upward moving blade. The angle of a kite diverts the flow of air unevenly over the kite. Air passing over the kite moves faster than air passing under the kite. According to Bernoulli's principle, the faster a current of air moves, the lower its pressure becomes. We see then that because of the air flowing over the kite is moving faster than the air flowing under the kite, the air pressure above the kite is lower than the pressure below the kite. The higher pressure below the kite pushes up on the kite to create lift. A helicopter uses different methods than any other aircraft. Its rotors or wings rotate in order to produce lift. In a hover, it is this rotation that is the sole producer of lift. In forward flight, however, the rotating disc of the helicopter's propeller produces additional lift by the rotation of the individual blades. Air moving across the outer convex side of the sail has a longer distance to travel in the same amount of time as air moving across the inner concave side. The air on the outer side is traveling farther in the same amount of time and has a higher velocity or speed than the air on the other side. This higher velocity air has more room to spread out, forming a low pressure area. On the inside of the sail, the slower moving air is packed together more densely, creating a high pressure area. This difference in the pressure on the sail acts as a forward suction or vacuum, producing lift. Horizontal wind turbine blades are usually made of 2 or 3 airfoils like a propeller. With these types of blades, it is the lift force which makes the rotor turn. When the wind hits the airfoil, the wind gets separated into two. It will pass over the top and the bottom side of the airfoil. Since the top distance is longer, the wind velocity will increase, therefore creating lower pressure on top of the airfoil. The lower portion will therefore have a higher pressure than the top of the airfoil, and this difference in pressure will result in lift. The lift force can be calculated from the following equation: L equals 1/2 P times V squared times A times CL, where L is lift, P is air density, V is wind velocity, A is surface area, and CL is the lift coefficient. One of the factors affecting the amount of lift created is the density of the air. The denser the air, the more lift is produced. This is why planes climb better in the winter. Colder air is denser. With speed or wind velocity, the faster the wing moves through the air, the more air is forced over the wing, therefore creating more lift. Another factor that can change the amount of lift created is the shape of the wing. Certain wings produce more lift. The coefficient of lift is a function of angle at attack. It is the angle between the lifting body's reference line and the oncoming flow.